faster. Yes, we're recording. Thank you so much. So just to recap, from this point going forward, the angles of the triangle will be capital letters. The sides opposite each angle will be a lowercase corresponding letter. So side C is opposite angle C, side little b is opposite angle B, side little a is opposite angle A, whether or not one of them is a right angle. And we started with an example where we have legs of measure 12 and 5, and we want to find everything else about that triangle. Well, we know that that a squared plus b squared is c squared, and therefore c is going to be 13. We also know if one of the angles is theta, one of the non-right angles is theta, the other non-right angle will be 90 degrees minus theta. So the first step always when you're solving a triangle is to draw it. And I'm trying to draw things so that it's shaking it up a little bit. I'm going to put angle C at the top where angle C is the right angle. That means that little c is opposite the right angle. And they tell us that angle B has measure 52 degrees. So I'm going to call this lower one B. That means that the side opposite will be little b. And that means the third angle has to be A. And the side opposite it is little a. One of the reasons why I'm drawing this in a weird way is that it doesn't matter how you draw it, you'll get the same information. They tell us little a is 11. We want to find all of the angles and all of the sides. And how can we start?
You can use the Pythagorean theorem.
Okay,
right?
But so far we only know one side.
I was going to say, we know that a triangle has to be 180 degrees, and we have 142 of them.
Yes, very
Oh, I
good.
misinterpreted because I saw it says C equals 90. I assumed we found C already.
Oh, okay. My mistake. So C is the angle. Capital C is the angle. Little c. Yeah, C is the only one where it really doesn't look different, capital and lowercase. So that was my fault. I apologize for that. So yes, we can find angle A because we know that A plus B plus C is 180. And we know B is 52 degrees and C is 90. 52 and 90 add up to
142.
So we know that A is going to be 180 minus 142. So it's 38?
Yes.
All right. Now we know all the angles and one side. Can we use trig? I'm going to redraw this so that it's prettier. Can we use trig to find a missing side?
Yes.
All right. How? What do we know, for instance, about B, since they gave us that? What is the sine of B in terms of the sides of a triangle?
B over C?
Well, yeah, tell me the opposite, adjacent, all that garbage. And
Uh,
yes,
it's,
Oh,
it's opposite over hypotenuse. So
okay. Yes, and so opposite of B is angle B is always going to be little b. And the hypotenuse will be always opposite the right angle. And so yes. Now, do we know at least one piece of that information?
E,
Do we know
yes.
either B or C?
Sine of B is the sine of 52.
All right, do we know one of the sides?
No, we don't.
Okay, can we write one of the trig functions of B where we do know one of the sides?
we could do
Would it be
sine of
cosine?
A.
Sure. We know cosine of B, and that's in terms of the sides of a right triangle, that will be
Adjacent over hypotenuse.
good. The adjacent side is going to be
11.
good. And the hypotenuse, of course, is C. So we get 11 over C equals the cosine of 52 degrees. I'm going to use my handy dandy phone. We want to make sure we're in degrees. On my phone, if I'm in radians, a little RAD shows up. So if I press the degree button, the RAD goes away, and that's how I know I'm in radians. I have 52 cosine. Gosh, let's see. Let's do a little bit more algebra. We know the cosine of 52 degrees equals 11 over C. What are we trying to find?
Or C.
We're trying to find C. Let's multiply both sides by C. So that now on the left, we have C times the cosine of 52. And on the right side, we have 11. How can we solve this equation for C?
Divide cosine 52.
Good. So now we get that little c is equal to 11 divided by the cosine of 52 degrees, and that helps me know what to put in the calculator. So I've got 11 divided by 52 cosine equals, and I want one decimal place. So what is side C to one decimal place?
17.9.
Good. So we know little a is 11. We know little c is 17.9. And these are just in units. How can we find b, little b?
Now that we have C, we can use sine B.
Good. So we know that the sine of angle B, it was B over C. I'm going to multiply both sides by C. And we get that side C is equal to side C times the sine of angle B. We know side C is 17.9, and the angle B is 52 degrees. And that'll give us side B. So let's see. I've got 17.9 times 52 Sine equals. Into one decimal place, what will be side B be?
14.1.
Excellent. When you're solving a triangle and your work is all over the place like mine is, it's always nice at the end to list everything, even the things you were given. So we found out that angle A was 38 degrees. We knew that angle B was 52 degrees and angle C was 90 degrees. Little a was 14.1 units, whatever they are. Little b, I'm sorry. Little a they gave us as 11. Little b was 14.1 and little c was 17.9. Is there a way that we can check our work? Something that we know about the sides of a triangle?
Pythagorean theorem.
Sure, absolutely. We know that a squared plus b squared should be c squared. So let's find 11 squared plus 14.1 squared and compare it with 17.9 squared. So what is 11 squared?
121.
Good. And somebody tell me what 14.1 squared is.
$1.99.
All right. Any decimal place?
It's 198.8.
Oh, okay, this is great. And then c squared. What is 17.9 squared?
320.41.
320 point.
41.
All right. And what is 121 plus 199?
320.
Excellent. Why do we have a slight discrepancy?
Rounding.
Rounding. Very good. Very good. And we don't care. When they say accurate to one decimal place, that means that there's going to be some error and we really don't care. I mean, we care, but we don't care. So I want y'all to do this one. So let's draw it in the standard way. I'm going to call angle C this right angle. Angle C, if there's a right angle, angle C will always be it. I'm going to let angle A be in the bottom, angle B be at the top, so that the hypotenuse is little c. Little a is the vertical side, little b is the horizontal side. And they tell us angle A is 20 degrees and little a is 5.2. I want y'all to solve that triangle. And while you're doing that, I'm going to go ahead and take roll. Could somebody let me know? Can you see my web page? The
No,
yes.
no.
Okay, good, good. I didn't want you to, so that's good. Very good. I want to try something. It's a whiteboard thing. Let's see if I can draw this. Oh, that's very ugly. So I'm gonna see if somebody else can draw this up here. And obviously it's not gonna be beautiful maybe, but that's okay, we don't really mind. But let's see if we can use this feature so that everyone can see someone's work. So who wants to volunteer to draw the triangle? First of all, can everyone, please let me know if you can see this whiteboard?
I can see it, but we all each have our own whiteboards.
Oh, okay. Every single person has their own?
Yeah. And we can also share our screen individually.
Okay, so then I want everyone, it looks like you can save your work on the whiteboard as either a PDF or a PNG. So I want everyone to do whatever work you've already done on the whiteboard. And then someone will share their screen.
Okay, can I do it?
Sure. Oh, it looks like
We
we
can
have,
only have one share at a time.
yeah, it looks like we have a common whiteboard. So yes, go for it.
We can only share one thing at a time. So someone else has to stop sharing so that I can share.
Oh, you know what, Alex? That means, oh, okay, that's okay. I'm gonna stop sharing. It's me. And I'm gonna do a whiteboard again.
I can just share my screen
Well, I'd
because
like
I'm
to,
doing this online anyway.
Yeah, so just let her share her screen, Professor, and then once the problem's done, you can revert back to your screen.
all right.
Unfortunately, Zoom is not giving everybody permission to share their screens multiple times.
Oh,
Not sure if
okay.
that's something you can change or is that something that's way up there,
I
so.
can't change that, no. All right, so Alex, go for it.
Okay, can everyone see?
Yeah.
Okay.
Yes.
Okay, so you found that angle B. Oh, good, okay. So you use the cosine of 70 is little b over c. How did you find little c?
s-
Oh, cosine. Okay, never mind. So cosine.
Sorry.
Yeah, you're right. Cosine of 70 is little a over c. Little a is 5.2. So yes, this is a way to find c. Okay, great.
Okay.
And how did you find that c was 15.2?
Sorry, give me 1 second.
All right.
Okay. So I found that. Sorry, were you asking about B
Little
or the
c.
hypotenuse? Oh,
Little
okay.
c, yeah.
So since cosine is adjacent over opposite. I don't know if you guys can see my mouse or not. I just put that into the equation. I didn't have C, obviously, but I had the angle and the adjacent side, and then I just did algebra to figure out that it was approximately 15.2, and then I used that information to find angle B, which I have to write here.
Okay. So 5.2 divided by cosine of 70. Very good. And yeah, how did you find angle side B? You used the cosine of 20?
Yes.
And you get 15.2 times
The
20,
cosine of 20.
14.3. Awesome. Okay. Very good. So let me show my screen.
There you go.
All right. Oh, let me see if I can set it up so that
Multiple people can. Yeah.
yes, share multiple participants can share simultaneously. All right. All right. I think I've set it up. That's a new thing that I can do. So I didn't know I could do that.
I was gonna say you should be able to because you're the host, which means you're the admin.
All right, great. So that means I should be able to keep this camera open and let y'all share also. So I just wrote down what Alex did. She found the third angle was 70 degrees.
Does it work?
Oh, yes, of course.
I don't think it works.
What do you mean?
I can't see your screen anymore.
I can see your screen.
You can see both of them?
Both of them? She's only.
Which screen are you not seeing, Alex?
I'm not seeing yours anymore. Like the one that you were just writing on. I'm only seeing my screen.
I don't see your screen.
I see your screen, Miss Nell, but I don't see Alex's screen.
Yeah, same here. I don't see Alex's screen.
That's weird.
Maybe if you minimize the one that you're seeing, Alex, maybe you'll see mine.
Well, it just said, I was just trying to see if both of us could share our screen at the same time.
Okay, okay. So it looks like we can't.
No.
Okay. Well, we'll try again in a minute. But I do want to check our answer. So we know that angle A was 20 degrees. Angle B was 70 degrees. And C is 90 degrees. Little a was 5.2. Little b was 14.3. And little c was 15.2. Whenever we have a right triangle, what can we use to check?
Pythagorean theorem.
Good. So it should be true that a squared plus b squared is the same as c squared. So when we're checking, we do the two sides separate of one another. And at the end, we see if we get the same thing. So we have 5.2 squared plus 14.3 squared. And the other side, the right-hand side, will be 15.2 squared. What is 5.2 squared?
It's 27.04.
All right. And 14.3.
Two hundred and 4.49.
What was the decimal?
49.
All right. And what do we get when we add those?
$231.53.
The decimal here doesn't really matter, but we're going to go ahead and leave it. What is 15.2 squared?
203.04. Sorry, 231.04.
Are we happy?
Close enough.
Close enough. Absolutely. Yay.
I don't know if I punched in the calculator wrong, but 27.04 plus 204. Oh yeah, I did. Okay.
Okay.
Belay my last.
Well,
I have a
let's-
question about
Yeah.
this question.
All right.
No, example 4.
Oh, the next one?
Yeah.
Oh, okay, great.
Yeah. So it says find the height of the kite to the nearest foot. The height from what?
Yeah, very good. So when they don't say the height with respect to what, you assume with respect to the ground. So if they just say the height, then they're talking with respect to the ground. It is,
Okay.
yes, very good. And I'll try not to use that language. This is an example I found.
So it's a plus 4 then.
That's right. So I know when you're out flying kites, you always measure the length of the string you're using. You make sure that there's no give to the string, and you know the angle with respect to the ground, always. But yes, this is a contrived example, but it's still kind of fun. So we want to find A, first of all, and then yes, we're going to add 4 feet for the child to whatever we find for A to find the total height. What can we use if we know the angle, the lower right angle is 42 degrees, and we know the hypotenuse is 120 feet?
You can find the other angle first.
Okay, what is the other angle?
48.
Good. Now what?
Now cos B is equal to 120 over,
Yeah, I meant to put C the second time. Okay, very good. So we know that the cosine of B is adjacent over hypotenuse. The adjacent side is A. The hypotenuse is 120. And I'm going to multiply both sides of this by 120. So I have 120 times the cosine of B is equal to little a. And what is, let's see, that'll be 120 times the cosine of 48.
80.29.
8, what is it again?
80.29.
And that'll be feet. And then what?
29.
Oh, thank you. let's see, Amanda must have gotten kicked out. And then what will, and how can we find H?
Add 4.
So we get 84.29. And how accurate do they want the answer?
To the nearest foot, so it would just be 84 feet.
Good. One thing about Connect Math that I really there are a million things I don't like, but one thing that I especially don't like, if you get the wrong, if you round to the wrong decimal place, it may say you're wrong, even though it's a rounding error and not a mathematical error. So make sure to read the question carefully. Again, that's another reason why we don't do exams or even reviews for exams online.
Yeah, it turns crazy real fast using Connect Math sometimes.
Yes.
What about the other question?
Oh, did I forget?
Yeah, it says find the horizontal distance of the kite from the beachgoer. B.
Thank you so much. Okay, so yes, we didn't find little b. I'm just out of it. How do you want to find little b?
We can do Pythagorean theorem since we have side B and A now.
All right, very good. So we know that side A is approximately 84 feet. And we're given that C is 120 feet. What is 120? Oh, 120 squared is 12 squared. 144 with 2 zeros minus, what is 84 squared?
Oh, sorry, I was muted. That was 7,056.
Any zeros? Oh, 7,000.
Yeah,
Okay.
7,000.
7,056. All right. And what is the difference here?
$7,344.
So that B to 1 decimal place, I mean to 0 decimal places.
Is 85.86, I guess.
So 86 feet. Great. Now I want to check. We've got all the information. We know little a. I'm going to go ahead and put it neatly somewhere. So angle A is 42. Angle B is 48 degrees. Angle C is 90 degrees. Little a, we found to be approximately 84 feet. Little b was 86 feet. And they gave us C was 120 feet. And I want to check the sides. So we use the Pythagorean theorem to find side B. How can we check using something else?
You got something on the notes, I mean on the chat.
Oh, okay, thank you. Thank you, thank you. Oh, okay, so we could use the cosine, thanks, Anna. So we could use cosine of 42, which should be little b over c. I can multiply both sides by c, and I get that c times the cosine of 42 degrees will be b, and c is 120. Cosine of 42. And Anna, you got 89? So,
She thumbs up on the camera, so I guess that means yes.
okay, thank you. That means we have two different answers for B. Which one is correct?
That's a good question. I would say the left side is, because that's the way we've always been doing it. But that's, yeah, I wouldn't
They're
know.
both correct.
That's right, they're both correct.
So
So
aren't they different?
they're
They're-
different. Why are they different?
One of them is exact, the other is rounding.
Well, they're both rounded.
So one is rounded more.
Right, one is rounded a lot more. That's right. So it's
That would be the Pythagorean version that's rounded more.
yes.
Yes, because we used rounded numbers and then rounded again.
Very good. So if you're
Which answer would Connect Math take?
well, that's what I was just about to say. If Connect Math ever says you're wrong, just send me one of those Ask My Instructor and I'll correct it. Don't do it again and again and get frustrated. Because they're both correct in my book. Now, I'm a really good artist, so I don't want you feeling bad about your own art. I'm kidding, right?
It's an impressive vehicle.
Thank you, thank you. So we
Better
have
than Picasso.
better than what?
Than Picasso.
And here's the building. So we know that the angle with respect to the ground of the ladder is 20 degrees. And we're trying to see how high I'm going to call this little a again. And we know that the ladder is 6 feet above the ground. We want to see how high up is this ladder reaching on the building with respect to the ground. I want y'all to do it now that you've got a picture. And somebody try to share. Do I need to enable whiteboards or can y'all just do that?
We have our own whiteboards.
Yeah,
Alright.
you don't have
Like
to
it's just
enable
one of the
whiteboard.
things we can share.
So somebody try to share a whiteboard.
I can try to share real quick.
Oh, I have a thought. Before you do that, let me check something.
I was also sharing at the same time Alex was sharing, just to see if multiple screens can, but I guess it didn't work that time.
So, okay, I thought I had a wrong setting, but I don't. So can anybody share while I still have a share going?
I can try real quick.
All right.
This is why Discord is a lot better in terms of sharing screens, because everyone can do it.
Can you see the whiteboard?
Oh, So I can't see your screen.
I
So I'm
can't
gonna-
either.
Okay, I'm gonna go ahead and stop sharing. There you are.
Okay. It's really hard to draw with a mouse.
Yes, it is.
Ah.
Beautiful.
The 20 the 20 degrees is on the other side.
No, that's right.
The top of the ladder makes a 20-degree angle with the building.
Oh gosh, you're so
Ah.
right. Okay, so I drew it wrong. Thank you. So very good.
I don't think it's gonna change the answer any, but it'll,
Yeah, it will.
let's see. What do I have? Oh, yeah. So then you have um let me calculate that real quick. So as far as height goes, yeah. So this is how far it is away.
Are you going to use the Pythagorean theorem?
I was just gonna do cosine.
Okay, good.
This is a lot harder than it should be.
Yeah, that's why I have this camera thing where I
You're
can.
doing great so far with the mouse.
Yes, much better than I would do.
Yeah, I think I better be doing good with this mouse. It was expensive. And then
Well, if you ever decide to invest in another monitor, you can always get a drawing tablet, which is like best of both worlds.
I have one. It's like it's not even really a tablet. It's just like a gray plastic thing that you like drag the little marker thing that came with it, and you have to like look
Oh,
at
I
your
know what you're
screen.
talking about. Yeah. You can't use that, or you just don't have it plugged in.
I just don't have it plugged in right now.
Oh, okay. You probably use that for rhythm games, huh?
I actually need to like get it get the sensitivity all plugged in and everything. 'Cause
Okay.
Right now it's a little wonky.
So you got 187.
What
Wait.
all are you figuring out?
He's checking. 1,413.76. What did you get for the sum? Oh, good, you're doing it.
So this is yes.
Oh, good. That's not bad. 0.45?
Yeah.
Okay, so it would round off to 5. Okay, very good.
Okay.
So let me share my screen again.
Yeah, I'll stop sharing.
All right.
Oh wait, so the height actually would be 43.6.
43.6, yes.
Okay.
So Gavin found all the information for the triangle. And
You don't,
go ahead.
do you need to find all the information?
No, but it's fun practice. So the only thing you had to find was little a and then h plus little a. Finding b just allows you to check your work. Any question before we move forward? All right. Find the pitch of the roof of a roof to the nearest tenth of a degree if the roof is 6 feet high at the highest part and 15 feet wide. And we're just going to assume we have a very boring roof that's symmetrical. And we're trying to find, what letter do you want to use for this angle here at the bottom?
A.
Okay, we're trying to find angle A. We are assuming that the lower angles are both A. And that this base, if we just draw the left-hand triangle, what is the base going to be of that triangle?
7.5.
Good. So how can we find angle A? In other words, what trig function involves A, the opposite, and the adjacent sides?
Tangent?
We know that the tangent of A equals 6 divided by 7.5, but we don't have A. So we want to do arctan.
Can't we get A though?
We're going to find A, yes. So we're going to find A by taking the inverse tan or the arctan of 6 over 7.5. And I think we haven't done any problems like this on our calculators, so this is good. So I've got 6 divided by 7.5 equals, no, I did that wrong. Okay, 6 divided by 7.5 equals, oh, I guess I did it right. And now on my calculator, there's a second button. And when I press it, all of the trig functions become inverses. So I can press the inverse trig and I get 38.65. How accurately did they want to know that angle?
10th of a degree.
10th of a degree. So what would our answer be for A to a 10th of a degree? Come on, there we go.
$38.7.
Good. So 38.7 degrees. Very good.
And we only used arctangent because the number wasn't, it wasn't a nice number or something.
Right. That's very good. Yes. So most of the time in real world problems, the numbers are not going to be nice. It's not going to be like 1/2 or square root of 3/2 or whatever. All right, from an eye level of 6 feet, an observer standing 30 feet away from a building. Okay, wait. So I've got a building. And 30 feet away, I have a person. Smiling. And his or her eyes are 6 feet up. Sights a building. Oh, sights the bottom of a window. Oh, this was a fun one. So here's the window. This one is loads of fun. So we've got the line of sight of the bottom of the window with the person's eyes and the line of sight of the top of the window. I'm going to use a different color. The top of the window with a person's eyes. And they're going to tell us both of those measurements with respect to the horizontal. The smaller one is 6.1 degrees. And the larger one is 20.1 degrees. In both cases, we've got a right angle. So let's draw the two triangles we care about. Let's see, let's draw them in the color that matches. So I've got the purplish color. The angle is 6.1 degrees. I don't know how high it is. I'm going to put A1. How do I know the base?
30 feet.
Good. And we're not going to worry about the 6 feet right yet. Now, we also have a triangle. I'm going to call, we know that its angle is 20.1 degrees. I'm going to call its height A2, just so that I differentiate them. What is its base?
30.
Good. And now let's make sure we've got all the correct information. So we've got things drawn. I'm probably not as good as y'all are about seeing all these things in my head. I have to draw them. But now that I've got everything drawn, somebody read the question again, and let's make sure we've got it correct. I'm going to zoom out. Oh,
I'll read it, I guess.
Okay, thanks.
From an eye level of 6 feet, an observer standing 30 feet away from a building sights the bottom of a window at an angle of elevation of 6.1 degrees. He sights the top of the window at an angle of elevation of 20.1 degrees. find the vertical dimension of the window, round to the nearest tenth of a foot.
Awesome. So what we know is, that the height of the window well, gosh, A2 is the entire height, including the window. And A1 doesn't include the window at all. So how can we find the height of the window?
A2 minus A1.
Good. So all we have to do is find A2 and A1, and we know how to do that. All we have to figure out is which trig identity should we use if we know the base and we're looking for the height.
We should use sine because it's opposite.
Sine gives us opposite, but does it use the adjacent or does it use hypotenuse?
Uses opposite over hypotenuse.
Sine is,
Oh, wait. Yeah.
yeah, we have opposite over adjacent.
Tangent?
Good. We know that, let's use colors. We know that the tangent of 6.1 degrees is A1 over 30. And we know that the tangent of 20.1 degrees is A2 over 30. Can I multiply both of those equations by 30? So that now we get 30 times the tangent of 6.1. That'll give us A1, and 30 times the tangent of 20.1. That'll give us A2. So somebody find 30 times the tangent of 6.1.
3.2.
So 30 times tangent of 6.1 degrees is approximately 3.2 feet.
Yeah.
All right. And 30 times the tangent of 20.1 degrees is approximately
11 feet.
0.0.
Yeah.
All right. And so H is approximately, we know that it is exactly A2 minus A1, but that's approximately
7.8 feet.
what will it be?
7.8 feet.
7.8 feet. Excellent. Big, big window. Does everybody, please ask if you have a question, please ask it in the chat. If you don't want to ask it to everybody. But does everybody understand the answer and how to get there? And did we need the fact that the observer was 6 feet tall? That's right. Very good. Well, this one is kind of fun. We've got an airplane flying. And I think we've got, all right, so we've got, it's descending. And it's going 200 miles per hour. The angle of depression is 15 degrees. Angle of depression is always measured with respect to the horizontal. want to find how far the plane will go in 2 minutes. So we've got 200 miles per hour and 2 minutes to figure out the length that we care about for the hypotenuse. What do I need to do to one of those numbers? Because right now we have miles, hours, and minutes.
Convert hours into 60 minutes.
Okay, so we want to start with 200. I'm going to write it straight up and down. 200 miles per hour. And we want to convert hours to minutes. How many hours are in 1 minute? Or how many minutes are in 1 hour? Whichever way.
60 minutes, an hour.
All right, that means we're going to divide by 60. So this is exactly equal to, can I reduce that fraction before we start approximating? It looks like I have 10/3.
You can do 50 over 15.
And that'll be,
No, it would be 50 miles over 15 minutes. You divide everything by 4.
okay. So we have 50 miles, 50 over 15 miles
Yeah.
per minute. Can we
And then
reduce that more?
Yeah, then it would be 10 over 3.
Good. So 10 over 3 miles per minute. And how many minutes? So distance, this is D is distance.
It was 2 minutes that we were looking for.
So distance is equal to rate times time. And yeah, how long was he going?
It was 2 minutes.
2 minutes, right. So we've got 10 over 3 miles per minute times 2 minutes. I'm trying to stay exactly correct until I can't anymore. So he went exactly 20 over 3 miles. So our hypotenuse is exactly 20 over 3 miles. And we want to find, let's label things. We know that this angle of depression up here is 15 degrees. Which angle does that correspond to in our triangle?
Okay.
Left one.
That's right. And we don't really care about the upper angle, angle this time. Let's call this angle A so that the opposite is little a. And let's call the base little b. How can we use the fact that we know the angle and we know the hypotenuse to find both A and B? Which trig function deals with hypotenuse and one of the sides?
We could do cosine 15 degrees.
All right, so we know the cosine of 15 degrees. And cosine is whatever what? Is it opposite or adjacent?
Adjacent.
Cosine, yeah, adjacent over hypotenuse.
All right. So adjacent will be b, little b. And we're going to keep our hypotenuse correct until we can't. 20 over 3. So that means to find b, I'm going to multiply both sides of this by 20 over 3 times the cosine of 15 degrees. That'll be b, exactly. And let's find, what does it say? How accurate? Oh, it doesn't say. So let's find the distance to the nearest 1/10 of a mile.
Be about 6.4 miles.
Okay, yeah, 20 divided by 3 times. Yeah, I got 6.4.
Oh, see, I meant 6.4. Yeah, sorry.
What is the exact value for the sine of 15 degrees? Well, sine is whatever what?
Sine is opposite over hypotenuse.
And the opposite is little a. And again, we're going to multiply both sides by 20 over 3. So we have 20 over 3 times the sine of 15 degrees. That will be a exactly, and we're going to approximate to 1 decimal place. What did y'all get? Good, that's what I got. Or did you get 1.8 or 1.7? Maybe I did it wrong.
I got 1.72.
Yeah, I got 1.72.
All right, that's what I got. And how can we check our answers? Good, very good. This is not a beautiful, there we go. How can we check our answer? Just to see if we're in the correct ballpark.
Pythagorean theorem.
Good. So let's go back up here and put, we know that A was approximately 1.7 miles. B was approximately 6.4 miles. And I'm going to keep C as 20 over 3 miles for as long as possible. A squared plus B squared should be the same as C squared. A is 1.7. B is 6.4. C is 20 divided by 3. What is 1.7 squared? Let's use 2 decimal places for a few minutes.
$2.89.
All right. And 6.4 squared.
That's 40.96.
Excellent. And what is the sum? What is 2.89 plus 40.96?
That is 43.85.
And that could go either way. We could round to 0.8, or we could keep it, or we could round up to 0.9. So we'll just leave it at 2 decimal places. 1d squared is 400. Is that right? Yes. And 3 squared is 9. So to 2 decimal places, what is 400 divided by 9?
That's a 44.4 continuous. So yeah, 444. Yeah.
And so are we happy? Where did we end up rounding? Because we didn't round the hypotenuse at all. But where did we round?
We rounded for side B and A.
That's right. And we rounded a lot. We took a lot of accuracy away from the cosine of 15 and the sine of 15. So we're very happy with these values. We got the same ballpark. So I know I didn't miss a decimal place, in other words. And as far as Connect Math goes, usually if you use the trig identities to find the sides, that'll give you the most valid answer that they are looking for, and then use the Pythagorean theorem to check. We're going to do just this one more section and then take a break. Bearings. I used to think that bearings only had to do with the sea, but that's not true. So to find the bearing from a point A to a point B, that is the degree measure of the acute, which remember an acute angle is between 0 and 90 degrees, formed by the ray AB and the north-south line. So for instance, here's the point B, let's say, here's the point A, and let's draw the north-south line. If we're going from A to B, then the angle that we care about is going to be this angle with respect to the vertical instead of with respect to the horizontal, like we have been doing. So for instance, say they give us that from A to B, we have north 42 degrees, and it's on the east side of the north-south line, so it'll be east. What would B to A be? What if we're going the opposite direction? Are we going toward the north or toward the south?
South.
Good. And with respect to the closest angle to the vertical, what is the angle going to be? Let's draw it so it's easier to see. So this time, instead of the arrow going up, it's going down.
Wouldn't it just be 42 degrees?
That's right. So south 42 degrees. And is it east or west of the north-south line?
West.
That's right. So you can see if you change the orientation, if you, instead of going from A to B, you go from B to A, the north becomes south, east becomes west, but the angle stays the same. So someone tell me from B to A in the second diagram, what is the bearing?
Wouldn't it be south 74 degrees east?
That's right. Very good. And what
Sorry, I
about,
was muted.
that's okay. And what about in the third one? We're going B to A. We know that A to B is south 40 degrees west. So B to A will be
That would be north 40 degrees east.
excellent. And finally, if we know that A to B is south 69 degrees east, then B to A would be,
That would be 69 degrees. Is that what it says?
I think
Yeah,
so.
69. Sorry. North 69 degrees west.
Excellent. So the west is, or the east is with respect to the north-south line. North is just above the east-west line, south is below. So let's use this diagram and see if we can find the bearings from O, which is the origin, to C. So how would we describe the ray from O to C? Is it below the north-south, below the east-west line, or above it?
It's below the east-west line.
Okay, so that'll be south. And what is the angle with respect to the vertical?
It's going to be 40 degrees.
All right,
Yeah.
all right. And are we to the right or the left of the north-south line?
It's going to be the right, so it's going to be east.
Good. So this is O to C. And we can just put a ray across the top. Instead of a line, we just put a little ray in the OC. All right, the next one we want is O to B. Here's O, here's B. But they don't tell us this angle. What do we know about that angle? Or what do we know that involves this angle?
It's equal to 180. Oh no, wait, to 90.
Yeah, we know that 118 degrees goes from the east axis all the way to B. So if I call this missing angle theta, we know that theta plus 90 degrees is what they gave us, 118 degrees. Does that make sense?
Yes.
So how can we find theta?
Just minus 90 degrees.
Good. And what do we get?
We got 28 degrees.
Excellent. So that means that, let's see, we're doing from O. So O to B will be, is it going to start out at north or south?
So O to B would be north
Good.
28 degrees west.
Good. Very good. What about A to O, where they give us the horizontal angle that OA makes with the positive east axis, but is that the angle we want?
No.
That's right. I'm going to call this missing part alpha. We know that alpha plus 22 degrees is 90 degrees. So that alpha is equal to
Alpha is equal to 68 degrees.
excellent. And so OA will have bearing. So it's from A to O.
It would equal, since it's AO, it'd be north 68 degrees east, right?
So we're beginning with A and going toward O.
Oh, towards O, so it's south 68 degrees west.
Very good. Very good. So yes, the direction is what this indicates. The angle stays the same. Once you find the angle with respect to the vertical, that will stay the same. But whether you're traveling down or traveling up has to do with whether you're going from the origin to A or from A to the origin. Any questions before we start to do some examples with bearings?
What is this for?
So,
Like
when-
practical application.
this is the first practical application. So when people tell the location of planes in the air, they usually give their bearing.
You hear this in movies all the time.
Yeah,
Not that I know if they're
Yeah.
correct.
so yeah, for instance, the plane leaves the airport at a heading or a bearing of south 32 degrees west, and it's going 320 knots, which is nautical miles per hour. We want to figure out the nautical miles per hour south and the nautical miles per hour west in 1.2 hours. So this is a lovely problem. We've got A, and I don't want to call it P. I think that's silly. Let's call it B.
But there's already a B.
Is there? Okay, thank you. I'm going to call this one C then. So from A to B, we know that our angle is 32 degrees. We know that we are heading south and that we are west of the north-south line. And what we want to figure out is, since it's traveling south 32 degrees west, how much of that is south and how much of that is west? So if we call this lower point B, we want to find the distance AB without the arrow, it just means the distance. And we want to find the distance BC. And we know the angle at the top here is 32 degrees. And the only thing that they gave us is the plane was traveling at 320 knots for 1.2 hours. And since knots is nautical miles per hour, we don't have to convert. We just need to multiply. So what is 320 times 1.2?
That's 384. Exactly.
Excellent. And I'm going to call this nautical miles. So we've got a triangle. The upper angle is 32 degrees. The hypotenuse is 384. And we want to find the base distance. What do you want to call that? Little a and little c. So how can we find this distance at the bottom, little a?
Wouldn't it be we would use cosine? No,
Let's
we
see.
wouldn't use cosine.
Cosine of 32 degrees. Cosine is what over what? I mean, in terms of the sides of a triangle?
It's where is it? Adjacent over hypotenuse.
So adjacent is c. The hypotenuse is 384. We can find c this way. So if we multiply both sides by 384, we find that c is approximately
325.6. 0.7.
Is it 0.6 or 0.7?
It's 0.65, so 0.7.
Yeah, it's 0.7. So
And this is measured in nautical miles. And okay, we found the vertical distance, with respect to our triangle. How can we find the horizontal distance? Instead of using the cosine of 32, what will we use?
sine.
Sine is what over what?
Sine is opposite over hypotenuse.
Good. Opposite will be little a. Hypotenuse is 384. And again, we're going to multiply. So we get 384 times the sine of 32 degrees. That's exactly a. So a is approximately
203.48, so 0.5.
good. Will the Pythagorean theorem show us that we're on the right track?
Yes.
Yeah, what will we be comparing?
So 325.7 squared plus what was our answer? 203.5 squared equals 384 squared.
And this was distance AC. So we had I'm just going to use the signs. So we have distance BC squared plus distance AB squared, and that should be the same as AC. Okay, what did you get when you squared 325.7? Let's do 2 decimal places.
Well, 106,080.49.
106,008.
Yes, 080.
0.49.
Yes,
All right. And then we're adding. What is 203.5 squared?
That would be 41,412.25.
All right. And what do we get?
A real big number.
All right.
I haven't done it yet. Let me type it in.
Yeah, put it in the chat. Did you put it in the chat?
Not yet. I'm
Oh.
typing it.
All right. Okay, let's see.
7492.25. Oh, I think I forgot to type the decimal on the 106,080. Let me fix that. Sorry. 0.49. It didn't really change the answer much. It was the same exact answer, but 0.74 instead of 0.25. Yeah.
So 0.74.
Yeah, 0.74.
All right. And what do we get when we square 384?
That would be 147,456.
Are we happy?
Yeah, it looks pretty similar.
Yeah. What they say in physics and engineering is order of magnitude correct. Order. Oh, let me let Clarissa just got kicked out. So they say order, magnitude, is correct. Or sometimes they'll say by order of magnitude, the answer is correct. What that means is we have the same number of places on the left. We are in the 100,000s on both. And the first numbers on the left are the same. In fact, the first 4 numbers on the left are the same. The highest ones. So we're happy. Why didn't we get an exact answer? Or a closer answer?
Because we use sine and cosine, and we didn't round it. I mean, we rounded less.
That's right.
Yes.
Very good. Very good. Okay, this is where we're going to take a break. I'm just going to set the timer for 10 minutes. Any questions before we go away?